Hello friends, how are you? Maybe all of you are fine and safe at your home. Friends, in the previous lecture, it means before our vacation, we have already learned about exercise 5.1, right? So we had already completed the first 10 examples related to the complex number, where we find that a complex number can be expressed as z equals to a plus ib. So now in our today's lecture, we have to solve another question. So first of all, I write the instruction. Instruction is this: find multiplicative inverse. Multiplicative inverse. It means reciprocal actually. Multiplicative inverse means reciprocal. Multiplicative inverse of following complex numbers. Complex numbers. It means example number 11 to 13 are there, where we trying to find out the multiplicative inverse. So let us start with the question number 11. Question number 11 is this: a complex number z is equals to 4 minus 3i. This is given complex number. So what we have to do? We have to find out the inverse. Inverse કેમ મળે? Here this z inverse can be written as 1 upon z. Inverse એટલે reciprocal is 1 upon z. So that is 1 upon 4 minus 3i. Now remember that when denominator is any complex number like a plus ib, then we have to applying reciprocal to it. So we will take reciprocal of it. So therefore z inverse is 1 upon 4 minus 3i, then multiply and divide with 4 plus 3i. Complex conjugate થઈ ગયો. તો આ યાદ રાખો, this is complex conjugate. So what we get? Numerator is now 4 plus 3i, denominator x minus y, x plus y, so x square minus y square, 4 square minus 3i whole square. What is this? This is 4 plus 3i upon 16 minus 9i square. Remember that 4 square 16 minus 9i square. This is 4 plus 3i upon 16 minus 9 into minus 1. ભૂલાઈ નથી ગયું ને? I think you do not forget it that I square is minus 1, my friend. Always remember that I square is minus 1. So finally this is 4 plus 3i upon 16 plus 9 is 25. And so we may write it as a plus ib. 4 by 25 is the real part. I into 3 by 25 is the imaginary part for this complex number. So this is the way to deriving it, right? Now the next question, question number 12. A complex number is z equals to root 5 plus 3i. Root 5 plus 3i. So again we are going to solve its inverse. So what is z inverse? We may say that once again z inverse is 1 by z clearly. So 1 by z means 1 upon root 5 plus 3i. But again we have to multiply and divide with its conjugate, the same method. Z inverse can be written as 1 upon root 5 plus 3i. So let me multiply and divide with root 5 minus 3i, right? So multiply and divide with this term. So numerator is again root 5 minus 3i. Numerator to आज रही. Now in denominator root 5 into root 5 is 5 plus minus minus 3 3s are 9i square. Remember that 3 3s are 9i square. What is this? This is root 5 minus 3i upon 5 plus 9. I just write as I square is minus 1. Okay, I write here. The reason is what? I square is minus 1. I think we know very well. Now this is a complex number which is of the form a plus ib, but we may express it as root 5 by 14. See, 5 plus 9 is 14 plus I into minus 3 by 14. Yes, is of the form a plus ib. So this is the method to find out the multiplicative inverse, or in other words we may say that this is reciprocal of a given complex number also, right? So let us solve the next one. The next question is question number 13. Is complex number minus I. Minus I is the complex number. Now what to do here? So here we may again write that Z inverse is 1 by Z, which can be written as 1 upon minus I. Now can you say that what to do? Again the process is say multiply and divide with its conjugate. So therefore I multiply and divide with its conjugate. What about the conjugate is minus 1 by I is this. Multiply and divide by I only. Negative I, so conjugate is positive I. This negative sign I write in numerator. So finally Z inverse is minus I upon I square, my friend. See here, बराबर ध्यान आप जो minus 1 into I is minus I into I is I square. Now what is I square? I square is again minus 1, and minus I upon minus 1 is plus I. See here, so inverse of this complex number is plus I. My dear friend, this plus I can be also written as 0 plus I into 1. Remember that. 0 plus I into 1. See here, this real part is 0. So if real part is 0, then a complex number is said to be purely imaginary number. Remember that when you get any complex number consists only imaginary part, that means the number is said to be purely imaginary number. So this kind of complex number where real part is 0. So I just write as a remark for you. If real part of Z is 0, then Z is said to be, or a complex number is said to be purely imaginary number. Is purely imaginary number. So remember that thing, purely imaginary number. Okay. Now the next question, example number 14 is this. Express the following polynomial in a plus ib form. Express into a plus ib form. A complex number is given, we have to express into a plus ib form. So a complex number is what? Let us see. A complex number, we may say that as Z. Z is equals to 3 plus I root 5 into 3 minus I root 5 upon root 3 plus root 2I and minus root 3 minus root 2I, or I root 2 is this. Okay. So let me solve it with help of this simple multiplication there, and denominator is also simple calculation. Z is equals to, I think you know that in numerator this is x plus y and x minus y. What is the product? X square minus y square. I can write this 3 square minus I root 5 square, and here let me solve this bracket. Root 3 plus root 2I minus root 3 and minus minus plus I root 2 is the term, right? And therefore this Z is equals to, our complex number Z is 9, 3 square is 9 minus 5I square. My friend, 9 minus 5I square. Okay, root 3 cancel. This is 2 times root 2I, right? 2 times root 2I is this. Now this is what? This is 9 plus 5. I square is minus 1 upon this is 2 root 2I, my friend. Therefore, this complex number is 14 by 2 root 2i. That can be also written as 7 by root 2i, but this is not of the form a plus ib. So again we have to deal with a surd. It means multiply and divide by I. So let us multiply and divide by I, applying surd, and therefore this complex number is now 7i upon 2 root 2 I square, root 2 I square, but I square is minus 1, do not cancel it. 7i upon root 2 into minus 1, or we may write minus 7 by root 2i. This is minus 7 by root 2i. What is this? Do you know that this can be written as a plus ib, like this? A plus ib means minus 7 by root 2. So this is the expression as a plus ib form. So a complex number can be written as in the form of a plus ib. Okay, my friend. One more example, let us solve. One more example is this. Solve it or convert it in the form of a plus ib. Let me derive one question. Convert into a plus ib form. First one is this: minus I into 2i into minus 1 by 8i whole cube is this. Let us solve what happened here. Then this complex number can be written as z is equals to, first of all multiply this two term, then minus 2i square into minus 1 by 8 whole cube individually and I cube. See here, this is what? Minus 2 into minus 1, because I square is minus 1. Okay, minus 1 cube is again minus 1. Cube is separately we may write, and 8 into 8 into 8 is 256, right? Sorry, 8 into 8 is 64, and 64 fours are 64 fours are, sorry, so that is 512. By mistake I derived this. This is what now I write once again: minus 2 into minus 1 into minus 1 by 512 and into again I cube. See here, what is this? Minus minus plus minus, minus 2i cube upon 512. So that is minus I cube. I cube can be written as minus I square into I upon 512. And what is this? I square is minus 1. So minus minus 1. Sorry, here is 216 into I by 216. It means our answer is I by 216. Okay, it can be written as a plus ib, like this: 0 plus I into 1 by 216, right? So this is very easy. Now to another example, let me give you in homework. The first one is this, or first one is this, second one is this: minus 5i into 1 by 8 into I. Just express it in the form of a plus ib. And the third one is 5 minus 3i whole cube. And the fourth question, find the multiplicative inverse. Find multiplicative inverse of 5 plus root 2i upon 1 minus root 2i. Okay, my friend. So try to solve this all the question yourself. And here we stop now. In the next lecture we will deal with another kind of topic. Thank you very much.